right, so welcome to today's lecture. What I would like to do is, first of all, talk a little bit, as I promised to you, about our progress. This is, we are almost at the end of the 8th week, and we are really in terms of lectures. And I wanted to just talk a little bit about where we are. And then also more specifically, since some of you asked to talk about and I wanted, as a matter of fact, to talk about the results of the midterm, how we did and what were some of the issues. I wanted to cover those. So I'm going to go to this one. This is, I took all of the grades we have available right now, and to those we are missing practically the two homeworks. The TA is still working on them. I think it takes him a little longer because he's grading with a great deal of attention to detail, but he promised to me to incorporate those grades in the next couple of days. So over the weekend, by the end of the weekend, you should have all of the grades incorporated. So this is everything we have up to now without homework 5 and 6. I don't expect this to change, to tell you the truth. Most probably the distribution is going to be exactly what you see. So I think in terms of a first cut, I'm okay with this distribution. I would like to see, of course, that moving up a little bit. We still have time, obviously. And then I would like to see those 8 students, the ones that you see, the ones down there. I believe there are a number of students who have decided not to participate in this class. A number of them have not submitted anything after, the second week or so. So, and I will contact them not just to make sure that they drop the class if they want to, because they're still listed. In any case, the rest of the class that I believe are the ones that have been active, I would pay attention to those 8. I think we have a lot of time to improve that and to move those 8 who are at the low end here, to move them up. That's my goal, all right? So the goal is to go here. So, this is what I see for the class. Obviously, you remember I told you, and then as we go closer to the last few weeks in the semester, I will be able to give you a better idea. But I will, while I have some projections about what we may get in this class, obviously we are not going to go that high. As you can see, we are going to put additional, of course, exercises, or it's going to be the project, and I may give the project for the final report more points and so forth. So probably will be around, I don't know what I had as a projection, but we probably be around above 3,000, considering the bonuses. Now, what I normally do with the bonuses, I don't incorporate those into the final grade. I put the bonuses aside, I look at the grades, and then the bonuses I use to move people accordingly. If somebody without a bonus is, for example, to get, is in one group of students, with the bonuses may move in another grade. All right, so that happens. So I'm not going to use the bonuses to really set the new grade, because then they're not a bonus, obviously. So that's one thing. The second, yes.
What grades are included for the 1530?
Excuse me. What do you mean?
What grades are included for the 1530?
Well, we don't have grades yet. I don't want to talk about grades. I want to talk about points. Usually my highest grade starts at the highest number of points without the bonuses that this class has generated. Okay? You
Uh,
look at your points. Yes.
Professor, so is this like correctly weighted? Because like this is, I assume this is just what's shown on eCampus, but
Yes.
like is the test weight a little more than 200, or is it like weighted exactly as points given?
No, it's weighted, it's just the points. You remember, I don't do anything. I will show you the points that we are getting. Of course, you need to understand. I don't want you to think about the grade right now. I want you to think about learning. I don't want you to go for a grade. I want you to go for learning in this class. The grade at the end, I have tremendous flexibility in giving whatever grade I believe reflects the learning of the student. So I just have to tell you that. If there is a student, so what that means, all right? If there is a student that for all kinds of reasons he or she thinks that they have enough points to go into one grade, but I have seen indications that this student did not really do the fair share of learning, did not get the fair share of learning in this class, I have the right to decide to do whatever I want with a grade. Now, with this, of course, I'm a reasonable person, and I always use reason, and I always do things that I can explain to everyone or anyone. So I will never do, I don't like arbitrary decisions myself. I always like decisions that are based on principles and they have clarity. And so, but I don't want you to think about grades because this does not reflect anything on the grades each one of you is going to get. We have long ways to go. So just make sure that you guys get the points right, that you learn, that you read the material, and that you come prepared. And then the grades will be the result of your learning. All right. So now I understand that we have been raised, all of us, in an environment where grades are driving. Well, I want you this time to think differently. The grade will be the result of your learning. And I have so many measures for this class that I know practically who, I may not know you all in person, but I know you by name and by what you're doing. So I know who has no problem and I know who has difficulties in this class. And so let's use the rest of the time, but I wanted to show you the points. Obviously, the grades will not be arbitrary compared to the points and what distribution of points we have. So I'm not going to take this and reshuffle it and give grades. I'm not saying that. But an individual who may be among the 24 now, if from now until the end of the class, I see a very low level of participation, even if the person, for example, does extremely well in the final for one or another reason. Final is one measure, get a lot of points, but is one measure. Then I will have to think of whether, especially for people who are somewhere in the borders between the two, there are a lot of people who fall in between. You don't see it here because they have been clustered, but there are a lot of people who fall in between. And there is where my judgment takes place. And I look at the whole progress of this individual. That's how I'm giving grades at the end. So why am I saying that is don't get hooked on the grades. For those of you who have done so well, don't believe you are out of the woods. For those of you who have not done so well, don't believe you are out of the woods. You still have ways to go and you have a capability of improving. That's all that I'm saying, all right? That's all, that's the message that I want to give you. Any other questions about that? So yes.
As I found, the total is not 1530. Total
What is it?
scores. Um, so I found this 1170, right? Oh, wait. I registered
So listen, let's not talk about this here because look at this. This is not my doing. It came out of eCampus.
Okay.
If the numbers you see are wrong, go and blame eCampus for it. So because these numbers, I did not transfer them, I downloaded, there was no human intervention in all of these graphs.
Okay.
Okay? All right. Now, let's move down. I don't want to argue about these numbers. If you have any discomfort with what you see or any serious questions about the math that eCampus is using to do these groupings, I mean, you know, I will have to learn more about how they do it, but that's what it is.
Professor, quick question on
yes.
that slide. Would you say that, like, as of now, like for a sanity check, like were the first three groupings being A, B, and a C respectively?
Not necessarily.
Okay.
I may give A. The A is going to be somewhere between the first and the second. It might be the first and the second. All right. The way it is right now, the last is going to be a C, unless I see those 8 moving up. In that case, and learning, in that case, then I may just give an A and a B. Or if I see total, you know, the class is falling apart, who knows what am I going to do? That's what I'm saying, all right?
Okay, thank you.
Okay. That's what I'm saying. Don't think that each one of them means a grade. No, means points. The grades are not going like that. I can give A and B's, or who knows what I may want to do if at the end I see that some people learn nothing, you know, in the class. So, you know, this is where it goes. Midterm grades, that's where we want to talk a little bit about. Now here, the picture is different. And we got, this one involves the bonuses. Obviously, you can see. We got from extremely well, and everybody who has, I believe, from 175, 180 and above is extremely well, to some people who did terribly. Okay, so let's think about what went wrong. And now, at the same time, I thought on the basis of the poll that one of you, and thank you for doing that, sent on Group Me, I thought that the majority of people thought that it was a reasonable midterm, all right? So for a reasonable midterm, I would have expected, to tell you the truth, this curve to be more like this one. Not with the numbers under, but just like the shape of the curve. I would have expected to be heavier on the front, which are the higher numbers, and thinner at the back, as opposed to what we see right now. So obviously we have some problems here. And I tried to put the problems together, and unless you want to stay on this longer, I would like to go to my notes and then talk about what I saw. Now, before I leave those graphs, are there any questions?
Yeah, how come it's out of 265? Is that just the way the histogram broke it up?
Yeah, that's
how
how the histogram does it. You know, you put those grades, you put them on Excel. That's what I did. Put them on Excel, and there is this software, this program, as you know, from Excel that puts them, that groups them. I did not do the grouping.
Okay, that makes sense. I was just making sure I didn't like miss 30 points, 35 points worth of problem on the exam that I just didn't see or something. Thank you.
Okay. All right. So that's the grouping done by Excel. As I said, everything is, I tried not to do it on my own because, first of all, it's very time consuming. I'm trying to do a histogram on your own, and then I used whatever tools I had available. All right, and I did not care this much. I mean, I do the histogram myself when we go in final grades, to tell you the truth. But not for now, this is pretty good. So where do I go now? I want to go to my notes. Okay, in fact, here it is. Here they are. My notes. And my notes, I will tell you what I saw. Okay. 13 students, and you can see that. I tried to count. Many students had more than one problems, but I will tell you that 13 students here took shunt for serious. And I looked, I thought, you know, maybe God, maybe I use shunt and the book uses parallel or something. And then I went through many chapters on this book. You never know, you know, it's, you never know how things go and how authors may have changed. But I have to tell you, everywhere on this book, if anybody had read this book, would every time they have a parallel stop, they will call it shunt. So here is what I want to say, and maybe you're going to tell me that I'm wrong, but I have to say that for these 30 students, they have not opened the book. 13 students in our class have not opened the book. Not even that book, any textbook. And maybe they have not read my notes, to tell you the truth, because always I use that term. And so, or the third possibility, which I don't necessarily want, I don't know, any of the three is not good. The third is that they were talking among themselves, and then somebody suggested that and everybody did the same. Who knows? I mean, I'm not going to police it, but I have three possibilities. All right.
I did a series stub, and that's just because that's what I was used to doing, and I hadn't practiced shunt as much. But I don't know, like I had looked through the books and stuff, and I, in principle, know how to do it. But when it came to like the timed exam, I just kind of fell back to what I'd done before.
I got it. Okay, well, sometimes I get to be, thank you for making this comment. I truly appreciate it, because sometimes, and I get, and I understand, I get to be very, in my comments, I get to be black and white. And that happens when I get a little bit frustrated, but I need to fall back a little bit, and I need to understand that we are all humans, and there are different conditions and stress, and then they may lead to this. Okay, I accept it, and thank you for telling me. I mean, you're grounding me right now, and that's very helpful. So
you're welcome. Thanks for understanding.
Oh, absolutely. I mean, I've been in similar situations where I was totally out of my space, and I could not even speak. I mean, I appreciate that. Thank you very much. So in any case, about that is the one thing. So that is fundamental, all right? So I removed points. The second one, and that I don't know how it came out, to tell you the truth, maybe because of the same thing, maybe because it's stressful, it's 1 hour, and people do not have the time to think clearly, or to cool down and think. Because when we're under stress, who knows, we make a lot of mistakes, personally and professionally. Okay, so I understand that when we put in this one, I would like to discuss it a little bit, because in retrospect, you will recognize it yourself. Maybe when you did it during that time, you thought it was okay. A few people, 12 students, and they are not different from the ones, these are not separate students. You can understand that some students may have more than one problems in their solutions. But in this particular one, people put next to Z naught a section of a line that was Z naught. What happens when we have a section of a line that is Z naught? Let me enter a page. Okay. Oh, all right. All right. So when we have a load here, okay, and then this load is, let's say this is 100 ohms for now, just to use a different number. And then you put next to it a line that has 100 ohms characteristic impedance. Or it could be 50 and 50, all right? How much is your input impedance here? How much do you think it is?
100 ohms.
Yes, 100 ohms. So practically, when then you normalize everything, so you can go to the Smith chart, when you normalize things, and then you normalize with respect to 100 in this particular case, what happens to, so this is your reference, what happens to all of these numbers? What do they become? This becomes 1, all right, normalized. This becomes 1, and this becomes 1. So why do I say that? Practically, a section of a line that has a characteristic impedance similar to the load, it does nothing else but bring the load where the beginning of the line is. So it's like a useless, for this particular case, is a useless addition to your circuit, because practically it does not do anything if the characteristic impedance of the line and your load are identical. Okay.
And this is the case where there's no reflections, right?
Yes, I mean, of course, if your load is different, if you have a load here, which is ZL, all right, let's assume your load is 100 ohms and your line is 50. That's different. It's not the same as I said before, all right? Indeed, a 50 ohm line is going to make a difference if you put, I mean, practically it's going to change a lot of things in the input. You're not going to have 100 ohms. However, when the two are identical, then practically the line does nothing, all right? So somehow, and I don't know whether the students who did that meant to show that this Z naught was not ZL. I think they incorporated a Z naught in many calculations, but the result that came out, I could not follow it, to tell you the truth. So the mistake started with that. It's okay to put a section of a line next to the load. You don't have to put the stub next to the load. You can put a section of line, but it cannot be that line. Any questions about that? Okay. The last thing I want to say is the following. Issues with the Smith chart. I've noticed, and I know that many of you have problems with the Smith chart. I've noticed that students have difficulty moving from impedances to admittances. I know it's complex, and the only way to solve that is to have many, to do practice. I don't know how else to say it, all right? Because you need to feel comfortable. If you practice simple problems with a Smith chart, then you're going to get better. It's not a matter of explanation. It's just a matter of practice. So the one thing that I do, because I'm a human too, all right, I cannot go back and forth. Usually I avoid going back and forth between impedances and admittances. When I choose to go with an admittance, I stick with it. When I choose to go with an impedance, I stick with it. And usually my choice depends a lot on the problem. Okay? Now, why did we go, and I have given you the solution for that. Why did we go to an admittance? Because as we said, when you have a shunt stub, what happens? You need admittances to sum up. You remember what we said? So what does that mean? That if I have, say, a line here, let's assume that I have a load, for example, just to make it simple. I have a load here, load. Somebody gives me ZL as a load. And then they ask me to put a stub here. All right? The equivalent of this stub is another load, a shunt load to the line. You agree? So whatever the stub is short or open, the equivalent to that is nothing else but my original load with a shunt element. Okay? Do you agree? Yes or no?
Yes.
All right. Now, when we have shunt elements, what is the best thing to do? The best thing we do is to work with admittances. Okay? Why is that? Because you sum up. You don't have to take the inverse and go into this very complex, and you cannot take inverses. I mean, the only inverse you can take in the Smith chart is to go from an impedance to an admittance. You cannot do multiplications on the Smith chart, all right? You can move on a line on the Smith chart and you can add the stub, and that's all. That's how far you can go. Move on a line and add the stub. The stub is going to be series if you work with impedances. It's going to be a series and you're going to work with impedances. And then you can deal with that on the Smith chart. If your stub is shunt, because the Smith chart can only sum something, reactive especially load, cannot do anything else, then you have to work with admittances if you have a shunt stub. So you change this into YL 1 over ZL, and then you deal with this stub here. Okay, so you never come back. You don't need to go back and forth because it's very easy to make a huge mistake when you start using the same chart for both impedances and admittances. Now, when you stick with a Smith chart, the one thing you have to remember is that your open and your short change. Like I have here, the blue, this is a load in impedance form. This is the same load in admittance form. Okay, if you use admittances, this point here is a short, because an infinite admittance gives you what? Zero impedance, which is a short. And if you work with impedances, the same point here is an open. Okay, so some students have had problem with that. I want to remind you. The other thing that I saw in a few, I cannot say that there were many, but attracted my attention. I saw some students who tried to move along these graphs. So let me do one more along these ones. Why can you not move on those graphs? What do you think? Who can tell me why it's forbidden?
Because your reflection coefficient or the magnitude of it is constant, so you have to move along the VSWR.
That's one. But why I would say this is forbidden? You cannot move along a line like this to go from one point to another. Why is that? What does it do? When I say that, you need to think, go to the fundamentals. Think, what is this line representing?
It would change your the resistance of your load.
This line shows constant reactance. So when I move from one point A of my line to another of this line, another point to another point B, these points A and B, which show impedances or admittances, depending where you are, they show that your admittances, since I have it with green, has the same resistive part, all right, or conductive, since we are the same real part, let me put it this way, and same imaginary part and different real parts, all right? So if you are for an admittance, you have the same susceptance, but different conductance. So the real part, just to be clear, the real part of your load, whether you are impedance or admittance, if you move along a line like this, changes, the imaginary part stays the same. What happens when the real part of your load changes? What does that really mean? what do you do into your circuit? When do you change the real part of your load? When you add or subtract what?
You're adding resistors in either series
Yes.
or parallel.
Series or parallel, all right? The subtract means you put them in parallel, but you do put a resistor. And resistors in matching circuits are a no. Why is that?
They waste power.
Losses.
Yes, exactly. Especially in passive matching circuits, where we have an option not to include resistors, then we don't. And why I'm saying passive? Because when you use active devices for matching, which happens in RFICs, for example, in some circuits, then unfortunately you have resistors that you have used for a number of reasons, either intrinsic resistances or some that you may have used for a bias. So what are you gonna do, right? I mean, so, and that's why active matching is not as good as passive matching. But in any case, so you never do that. So never move on these lines. So you have to understand that. I think that's what the major things that I've seen. There was another thing that I in problem 2. While many people gave me the good definition for conjugate matching, in problem 2, they had serious problems trying to implement it. All right. So here is what I would like to do. You remember I told you a little bit. Here's what I would like to do. I will give you the same meter as a homework. I will write it down, but today, and I will put it on eCampus, but I will tell you right now what my plans are. Obviously, I just don't want to make sure that everybody shows me the right solution. You're going to get a grade for that as a homework. But in addition to your points, I mean, grade, points as a homework. But in addition to points for the solution, I would like to do a critique on your solution. I don't want you to explain only, and I don't want you to apologize or anything. Like a critique, when we say, when we say critique, is not like a personal account of things. A critique like we do in papers. So for example, when I send my paper to and is published, and another author makes a comment on my paper that says that so and so, it has been wrong or it has been inaccurate, and when they say that, they explain why they suspect, because sometimes they're not 100% sure, why they think so. All right. So they use evidence to explain why what I proposed was not correct. This is called critical critique. So it's not like I did not feel good. No, I mean, of course, I do not. I can understand that piece. You can tell that to me in private. But when it's a critique of a document, it's not like that. I don't want you to do a personal account of things. I want you, on the basis of what you know, to explain, as I did. See, when we talked about this, and I wrote things under, I told you in the beginning, I understand how some people can make this mistake. But so for those of you who have made this mistake, I will understand if you tell me, and I don't want you though to say that there. That's not critique. If you say to me in private, or you write a different note and say, that did not feel good that day, I was totally, confused. I did not expect that, whatever. This is not part of the critique though. In the critique, I want you to tell me why this is not correct, using the theory that we've learned, like we did in this one and we did in this one. All right. We explained why it's not right. So I want you to critique your own work and then provide the correct solution, but explain. That is very important to me. I will give you for that critique additional bonus points. But I will be now I grade it kind of generously. In the critique, it has to be right. There is another thing that I would like to encourage you as well. When I saw you, I gave you two narrative questions. One about the conjugate matching and the other about resonance. I know because of time and so forth, with some individuals, I could not understand what they were trying to tell me. So communicating clearly is as important as writing the correct thing. Because if you communicate it clearly, even if you try to tell me the right thing, I will not be able to understand it. So when you do provide me the solutions, and I have to say, when I looked at your projects, I'm very happy with the quality of your work in your projects and the quality of the presentation. I have to say that, all right? I'm very happy because of the way you present things for most of you. And there are small exceptions. But I would like you to do this one in this homework. Always try to communicate clearly. It's extremely important. It's going to be extremely important for your own professional career to be able to explain to people, even when you have done something wrong. Explanation is extremely important. So that's what I wanted to say. I know that I took quite some time, but I believe this is very important for me and for you. All right. We have many weeks to correct. And I believe that if we do it right, we will get where we want to be. Because at the end of the day, I want you, it's not like that my goal was for you to get an A in this meter. My goal is to learn from it. We mostly learn from our mistakes. You need to remember that. Many times we don't learn from the times we have been successful because we tend to forget them, but we never forget our mistakes. At least, and then, so I'm not suggesting to use a mistake to beat yourself down. No, use it as an opportunity to learn. When I was taking my PhD, I was my fourth year and I had no results whatsoever. And what would you do if you were in fourth year, you were married and with a baby and no results for that? I mean, a lot of people will say, okay, I'm leaving and I'm going home. Well, I did not do that. Thank God I had a great advisor, but I was able to think every time I was writing these huge programs at the time to do, I was developing software. And every time I would find a mistake in my code, I will go home and say, thank God, one mistake less. That's what really took me through. And I was able in a year, because I was able to quickly find, I was working on this for a long time, but I wanted to tell you, that's the kind of approach and attitude you need to have. Every time you find a mistake, you have to learn from it and you will tell yourself, one mistake less. And that's what is going to move you forward. So I just want to tell you that, I hope that I hope that a class is not just to teach you few rules, but also to teach you how to use the rules and how to think about not only surviving the class, but thriving through it. In any case, that's what I wanted to say. And I would like to stop and hear any comments at this moment.
Is this the end of class?
Or... No, we have about 10 more minutes.
Okay. I'll ask you after class.
Okay. It sounds good. So what I would like, any other comments related to that, or you're ready to move on?
I have a question.
Yes.
I remember you explaining at one point why you put the stub before the transmission line, but I forgot the reasoning for it.
What I said is, yes, what I said is the following. A lot of times, in practice though, all right, not for, if I want you to not do that at one particular case, I will tell you. But practically, if somebody, and you will see that from filter, in fact, the filters will be the best. So if you can wait, can I go to filters and explain it there?
Yeah, that'd be all right.
Okay,
Thank you.
perfect. I just want to make sure that you don't add, because you don't know what your load is. You don't want to be too close to the load when you add things that may be different. They may have size, and they may change the geometry
Okay, so it's like a
dramatically,
loading
like it's a
issue.
stub. Yeah, yes. So you will see that in the filters, because that's what the Carota transformations will do. So in fact, that's what I want to do. Go, and I will upload this on your after today's lecture. So what I would like to do today, we stopped here last time. We did our filter. It had lots of elements. It had 10 elements, 5 stages, 10 elements, because it became a bandpass. Now, before we go back to it and see how do you materialize something like that, of course, it's going to be kind of complex. I wanted to then stop at that point and then introduce the Carota identities and explain why we have them, and then go back to filter like this. But I will this is the table. I'm not going to spend my time on the table. I will start working on an example, and then I will refer to the table, if that's okay. I don't want to just use the table, because it's not going to mean much to you from what you see. All right. So do you remember? You may remember that some time ago we solved the first low-pass filter we did had these specs. And doing that design, it's a part of those nodes, and it's very early as part of those nodes. So you can, if you are on this, if you have this file in front of you, you will see it in the beginning of the file. We found from that design, using the prototype, we found this simple filter. So I'm going to use the Carota transformation on this simple one that has 2 elements, 2 stages. Okay, so I rewrite it here. I'll do it in a general form. You see, we have an LC, and we have an input line of Z naught and a load of Z naught. And I represent it with another line at the output. Okay, what I now want to do is the following. Let's look at this. And then let's assume that I want to tell you, you know what, I really like to materialize that using microstrip. So could you try to see how we're going to do that? What is the first thing that jumps up from that? The first thing is, first of all, one realization that both C and L are reactive elements, individually, all right, reactive. That means that I can, if I want to materialize that using microstrip, how would I do that? Using stubs. Is that right? Do you agree with that statement, that my first thought will be to use a stub for each one of them?
Yes.
Okay. Yeah. So for the shunt, I will use a shunt stub. And for a series, I will use a series stub. Okay.
And that's because that's a lot cheaper than like an inductor or capacitor, like an actual inductor or capacitor implemented by a microstrip.
Well, let me get that. So we want to do it in microstrip. Exactly. I mean, we don't want to have an LC, lumped LC. Of course, in high frequencies, you don't have lumped elements. All right. Even if you have passives, you may say, well, what if I am on a CMOS substrate and I'm using a capacitor, an MIM capacitor for C, and then I'm using a spiral inductor for L. You can do that too there. But in this particular case, I asked you to use a microstrip lines to do it. Okay, so I did not tell you you could. I mean, if you are in RF in a CMOS environment, and if your inductance is not huge, and your capacitance is not very large, you can do small capacitances and small inductances as lumped elements. But the moment that the values become very large, like it is for a filter, if you are in high frequency, it's going to be very hard to do. Okay. But in any case, without having those considerations, I just ask you, use microstrip lines or microstrip line. You are in a microstrip line environment, try to develop this filter. So I would think, okay, a stub for shunt, because that's what we're using for distributed, a stub for the series L. Okay, the shunt, I know how to do in microstrip. You remember we said in microstrip, a shunt stub is the easiest one to make. From two possible shunt stubs, one with a short and one with an open, the easiest one to make is the one with the open. Do you agree?
Yes.
Yeah, because you don't have to drill a hole. Okay. So now I'm done. You say theoretically or conceptually, I'm okay with the capacitor. But then the inductor creates a problem for me because I know that in microstrip, I cannot use a stub in a series configuration. So if I were to replace this L with a stub, practically the stub would look like this. All right? But I cannot create a series stub in microstrip.
That's a series stub.
Uh-huh. I cannot create a series stub in microstrip. You know how a stub in microstrip will look like? If I were to do it, it would be a line, because I can only, okay, let me in fact do it on a separate page. Okay. So our microstrip a microstrip looks like this. All right. So there is nothing I can do on the ground. The ground is unperturbed. But the only thing that I can do as a microstrip is to have a mic to take the. I have to interrupt the signal line. I have to do a series stub, which is like this on a line, if you remember. You interrupt one line. You just don't connect to it, you interrupt it totally. So if I have a microstrip and I look it from the top, the microstrip from the top, a single line will look like this. All right. And let's assume that this is this part. And this is this part. All right. From the top. Now I want to put, this is point A and this is point B. I want to put between point A and point B a stub. So I have to break this one. So practically, I will have to break it first of all. Okay, and then what would I have to do? If I have to break it, then I will have, the only way to do it is to do something like this, and then do something like this. But this doesn't work. Because in microstrip, there is another phenomenon that we have seen, which is called coupling. The coupling is extremely strong and extremely important. If to avoid coupling, you will have to move these lines, these two, very far away. What does it mean, coupling? Think of one wire that creates a magnetic field like that. All right. What happens if you put another wire in there?
That generates a current in the other wire.
Exactly. So there is coupling between two. So one wire is going to generate a current in the other. And so these are two coupled lines. They are not a transmission line. In the transmission line, on one section of the line, So if I put two transmission, let's consider a transmission line like a two-wire transmission line, all right, which is like this. In a two-wire transmission line, let's assume that I have one wire here, one wire there. In a two-wire transmission line, what happens? One current goes like that, the same current comes back. Do you agree? But if I put these two wires too close, then, and like this, in this specifically out of microstrip, then one current is going to go like this, and then instead of the same current going back, it's going to be a different current that comes back. Yes, something is going to go back, something is going to have a different direction, but it's not going to be, the currents will not be identical and have opposite directions. They will be different and may have the same or opposite, depends on how strong the coupling is. So this is going to be like a transformer, all right, instead of being a transmission line. So we don't do that practically. And that's why in transmission lines, what we are trying to do is to always put shunt stubs, always. If we have to put a stub, always shunt, okay? Is that clear? All right, now, yes.
Is there ever really a time we're going to use series stubs then?
Yes, in other transmission lines. There is a, for example, you can use a series stub in a coplanar waveguide. The coplanar waveguide looks like this. People have done it, but not in microstrip. Let me just say this much. I don't want to confuse you with other things. Yes, but most of the time, however, in microstrip, remember that all of the stubs are shunt. Okay, all of the stubs are shunt. All right. I would finish here because we have already passed, but you may want to look a little bit, we'll cover this on Monday. You may want to look a little bit down here in the rest of the notes to see how we transition that. And then practically, I will talk about the other issue of where do you put your load, if you have a load, or how do you design your filter. But if you can look a little bit in this, in the rest, then before we come together on Monday, I will be able then to, I will be able to cover this and then move on. The one thing that I wanted to tell you is that there are a lot of things in the filters, but I decided we don't want to see everything in filters. We'll only see some low pass filters. For band pass, I'm not sure we are going to do it here because for your designs, you will need low pass filters practically. So what I would suggest is that we cover low pass well. And then over like tomorrow, I'll give you your next project, which might take a little longer than a week for you. And I will give you more than a week, but the next project I will ask you to start in your system that you have, a group project, all right? In your system that you have selected to start designing with microstrip your filter. One or more if you have. They will be all low pass filters from what I've seen. So you will have to start doing those designs. And if you have a bandpass filter somewhere, I will go back. You need to discuss how you're going to do it because it might be, we will not have enough time to cover all of this in the class. So let's think about it. All right. For those of you who think of doing bandpass filters, you may have to rethink a little bit your architecture. So you can deal with low pass filters, going to be easier. All right. Any more questions? Okay, I will see you during office hours. Now, you want to speak with me, Zehin?
Yeah, you can call Neil for your convenience as well.
Pardon me?
You can also call me Neil for your convenience.
Oh, okay, thank you. Yes,
okay.
Neil.
Some students said you didn't receive my submission, but I in my sent box, I can see I submitted on that day.
So that's interesting because I could not find it.
Are you able to use the search function for your email?
Oh, in the email you send it to me.
Right.
Okay. I also checked my email through search.
Oh, okay.
And I could not see it, but you never know. I will do this again.
Okay, I resent you just today.
Okay.
Yeah.
Okay.
I mean,
All right.
at first I sent to you on September the 30th, 2:29 p.
Okay.
Wait,
No,
2:32
that's all right.
p.m. And
Okay.
but because I used a Chinese scanning app on my cell phone, and I forgot to rename the title, and I assume you cannot understand Chinese, so I resent it at
Okay.
40 p.m. on that day.
Okay, I'll find it. Yeah, I may have not done a good search. And
Okay.
yeah. Okay.
Okay.
Yeah.
And by the way, for the midterm solutions, I don't know how you found the purple line. I know how to find the circle, the red lines, and the green line, but I don't know how to find the purple line.
What is the purple? Where?
The midterm solution.
In the midterm. Okay, that's okay.
If you are, if it takes your time. Oh, only hosts. Hosts disabled.
No, that's okay. I can look a midterm. Let me see solutions. I have them somewhere here. It's like, why do they have like name?
The first.
Okay.
The first
Find it.
Solution.
This one. The purple you don't know how to find.
Right.
Well, we will have to talk about this and do some examples. Maybe if you come during office hours, or if you cannot come during office hours, ask me to meet another time over Zoom.
Okay, I'll try to office hours starting from 3 p.m., right?
Yes, exactly.
Oh, okay. Okay, good. I'll try to reach you at that time.
Okay, thank you.
Bye.
Bye.
Dr. Katehi? Dr. Katehi, can you hear me?